everyone, welcome back to Food for Thought. Today we're going to be talking about chemical reactions. How do atoms combine? We know that atoms have to mix together to form many of the molecules that we see in our everyday lives. We're going to talk more about the specific mechanisms behind reactions later, but for now the most important thing to remember is that mass is conserved. So nothing can be created, nothing can go away. What you have on the right side of the equation is going to be what's on the left side of the equation. Now, we could have them scrambled up. So if we have blah on the left side, it could go to, abl on the right side. But the important thing is that the same amount and identities of all the atoms are there. So, for instance, we're going to talk about water. You've all heard of water, I hope. So, we're wanting to make H2O. But H and O, hydrogen and oxygen, just don't show up as single atoms in real life. They're going to show up as H2 and O2. These are what's called diatomic molecules. And at room temperature, they'll be gases, but that's not important right now. So what we want to do is have H2, which is a gas, hence the little letter G, plus O2, which is a gas, form H2O, which at room temperature is going to be liquid. Now, if you look on the left side, you see that we've got two H's and two O's. And on the right side, we have two H's, but we only have one O. So this is a problem. Because remember, we want to have everything be the same on the left and right sides of the equation. So what we're going to do is we're going to put what's called coefficients, which is a fancy term for numbers, next to the H2 and the O2 to try to balance the equation. So if we look, we see that we need to have twice as many hydrogens as oxygens. So what we're going to do is we're going to have 2H2 plus O2 going to now 2H2O. Now if we check, we have 2 times 2 or 4 hydrogens and 2 oxygens. And on the right we have 2 times 2, which is 4, and 2 oxygens. So this equation is now balanced. The study of balancing equations is going to be called stoichiometry. And this just means that we're going to be figuring out how much of each substance we need to balance an equation and make another compound. So let's take another reaction. We're going to be reacting aluminum, which is a solid, and hydrochloric acid, which is going to be aqueous, but we're not going to worry about that right now. Aqueous just means that it's dissolved in water. And we want to make aluminum chloride and hydrogen gas. So how do we balance this? Pause the video if you want. All right, welcome back. We're going to figure out how to balance this equation. So we know that we have one aluminum. That's all great. But we want to figure out how many chlorines that we're going to have. We know that we have 3 here, so we need to have 3 here. But we also have H2. So whatever the number is next to the HCl needs to be a multiple of 2. Smallest number we can think of that's a multiple of 2 and a multiple of 3 is going to be 6. Which means that we're going to have 2 AlCl3, because 2 times 3 is 6, and 3 H2, which means that on the left side we're going to end up with 2 aluminums. Another example we can do is going to be iron sulfate and barium hydroxide. So this is actually the answer. So kind of spoiled that for y'all. But you can see that if we had had just the iron sulfate and the barium hydroxide, we would have first needed to balance out the number of sulfate ions. So in general, you want to start with the compound with the most atoms. This allows you to then work out the rest of the equation. Most of the time you can guess and check. Sometimes you'll need to use algebra. It's not hard. If you want to look online, you can find tons of examples of how to use systems of equations. So this is just a little bit about how to balance reactions. Now, what kinds of reactions do we have? So first, we're going to have precipitation, also known as double displacement. Now, these are not necessarily the same, but basically, in a double displacement reaction, two things get switched. So one example is going to be silver nitrate and sodium chloride going to silver chloride and sodium nitrate. Notice how the nitrate ion and the chloride ion switch places. Now in this case, this is also going to be a precipitation reaction. Because if you recall, we know that nitrates are always soluble. So this is an aqueous solution. Sodium chloride is soluble, so that's an aqueous solution. And again, nitrates are soluble, so sodium nitrate is soluble, but silver chloride is not soluble. So this is going to be a solid. And this is what we call a precipitate, which is just anything that comes out of solution. Next, we've got acid-base reactions, which I'm sure you've heard of. You know, you've heard of baking soda and vinegar, all sorts of cool stuff like that. Now, in this case, we're going to use an example of NaOH and HCl. So this is sodium hydroxide and hydrochloric acid, and they're going to form NaCl and H2O. So whenever you have an acid and a base, you're going to get neutral products. Now, sometimes that's going to be water. Sometimes that's going to be a salt like we have here, NaCl. Sometimes it's going to be CO2. And it just depends on what the acid and base are. We're going to talk more about those in a future lesson. These are one type of oxidation and reduction reactions, also known as redox. Again, we'll talk more about those later. This includes single displacement reactions and combustion reactions. So basically, in oxidation and reduction reactions, you have a transfer of electrons. This can take many, many different forms. One simple one would be a combustion reaction. And of course, I'll leave this as an exercise to use to you to balance, but it goes like that. That's how you balance it. So you notice here that the oxygen is going from a +0 over here to a +2 over here. Sorry, a -2 over here. And it's going to a +2 over here and a -2 over here. So the oxygen is both oxidized and reduced. Reduced just means that the charge is lowered. And we'll learn more about these later. But for now, you can just remember Leo Ger. Loss of electrons is oxidation, and gain of electrons is reduction. So these are all the simple types of reactions you'll need to know for now. Later on, we're going to get into redox and acid-base chemistry and how they work. But for now, remember to always check your coefficients and always conserve your mass. See you next time.